Section 9.2, Systems of Linear Equations, Solutions by Substitution. The objective, use the method of substitution to solve systems of linear equations. To solve a system of linear equations by substitution, your procedure is to, step 1, solve one of the equations for one of the variables. Step 2, substitute the resulting expression into the other equation. Step 3, solve this new equation, if possible, and then substitute back into one of the original equations to find the value of the other variable. This is known as back substitution. Step 4, check the solution in both of the original equations. Example 1, solving systems by substitution. Use the method of substitution to solve the following system of linear equations. X equals -5, y equals 2x plus 9. The first equation is already solved for x. Substituting -5 for x in the second equation gives the corresponding value for y. Y equals 2 times -5 plus 9, which is equal to -10 plus 9, which is equal to -1. When you're using substitution, it is always easier if you actually use an equation where one of the variables is already solved for you. It eliminates part of your steps. And in reality, both of these were solved for one of our variables. The solution to the system is -5, -1. Our x value, -5. When we did the math here, our y value became -1. Check. Substitution shows that -5, -1 satisfies both of the equations in the system. So our first equation was x equals -5. Our second equation, y equals 2x plus 9. Plugging in the ordered pair, which in the first equation is just plugging in the x value, we have -5 equals -5. In the second equation, we plug in the whole ordered pair, -5, -1. It ends up giving us -1. Does that equal 2 times -5 plus 9? That ends up simplifying into -1 equals -1 on the right, and we already established that -5 was equal to -5 on the left. So it worked. Example 2, solving systems by substitution. Use the method of substitution to solve the following system of linear equations. Y equals 5/6 x plus 2. 1/6 x plus y equals 8. Again, the first equation is already solved for y. Substituting 5/6 x plus 2 for y in the second equation gives the following. 1/6 x plus 5/6 x plus 2 equals 8. We're going to multiply both sides by 6, or the lowest common denominator, so that we can eliminate having a fraction. So I'm going to take 6 times 1/6 x and 6 times 5/6 x plus 2, and I'm also going to take 6 times 8. When I simplify that, that leaves me with x plus 5x plus 12 equals 48. X plus 5x is 6x plus 12 equals 48. Subtract 12 from both sides, leaves me with 6x equals 48 minus 12, which is 6x equals 36. Now I'm going to divide both sides by 6. X gives me 6. Substituting 6 for x in the first equation gives the corresponding value for y. Y equals 5/6 x plus 2 was our equation. We're going to replace the x with 6. Y equals 5/6 times 6 plus 2, which is equal to 5 plus 2, which is equal to 7. The solution to the system is 6, 7. Checking that, substitution shows that 6, 7 satisfies both of the equations in the system. Y equals 5/6 x plus 2, and 1/6 x plus y equals 8. On the left, 7, does that equal 5/6 times 6 plus 2? And on the right, 1/6 times 6 plus 7, does that equal 8? Simplifying those down, on the left, 7 does equal 7, and on the right, 8 does equal 8. Example 3. Use the method of substitution to solve the following system of linear equations. 3x plus y equals 1. 6x plus 2y equals 3. Solving the first equation for y gives y equals 1 minus 3x. The reason we did that is because no coefficient in front of the y makes it the easiest one to solve for. Substituting 1 minus 3x for y in the second equation gives us the following. Again, we have 6x plus 2y equals 3. We're going to replace the y with 1 minus 3x, which gives us 6x plus 2 times 1 minus 3x equals 3. Distribute, and I have 6x plus 2 minus 6x equals 3. When I simplify that down, you'll notice that the 6x minus 6x is going to add to 0, and that leaves me with the statement 2 equals 3. This last equation, 2 equals 3, is false. This tells us that the system is inconsistent and has no solution. Graphically, the lines are parallel and there is no intersection. Example 4. Use the method of substitution to solve the following system of linear equations. X minus 2y equals 1. 3x minus 6y equals 3. Solving the first equation for x gives x equals 1 plus 2y. Once again, we have the coefficient in front of this being 1. So that's the easiest one to solve for. Substituting 1 plus 2y for x in the second equation gives us the following. 3x minus 6y equals 3. Substituting 1 plus 2y in for x, I have 3 times 1 plus 2y minus 6y equals 3. When I distribute, I have 3 plus 6y minus 6y equals 3. And I have 3 equals 3. And once again, the plus 6y and the minus 6y are going to add to 0, and I have 3 equals 3. This last equation, 3 equals 3, is always true. This tells us that the equations are dependent and that the system has an infinite number of solutions. The solutions are of the form 1 plus 2y, y, for all values of y. Or if we'd solved one of the equations for y, we have x, 1/2 x minus 1/2 for all values of x. Example 5. Use the method of substitution to solve the following system of linear equations. Solving the first equation for y gives y equals 5 minus x. We could have solved for x or y in that first equation. That would have been a smart move either way. Substituting 5 minus x for the y in the second equation gives us the following. So there's our original equation. 10 times 0.2x plus 0.3y equals 10 times 0.9. What we're doing here is multiplying 10 so that we will have coefficients that are constants. We don't want to deal with decimals. So that's going to be actually our first step before we plug anything else in. That ends up leaving us with 2x plus 3. And here we are going to replace our y with 5 minus x equals 9. Distribute, and I have 2x plus 15 minus 3x equals 9. And when I put like terms together on the left, the 2x minus 3x gives me negative x. Subtract the 15 from both sides, gives me 9 minus 15 on the right. So negative x equals negative 6. Divide both sides by a negative 1. X equals 6. All right, and then to figure out what my y value is, I'm going to plug in the 6 into my other equation. Y equals 5 minus x was the equation. So I have 5 minus 6 equals negative 1. The solution to the system is 6, negative 1. To check, we would substitute x equals 6 and y equals -1 in both of the original equations.